Hi grade 7s, welcome back to another one of our video lessons. Today we're going to continue with decimal fractions, which is topic 7 on page 90. Remember in the last few lessons we did common fractions. We looked at numerator, denominator, improper fraction, a mixed number fraction, and how all of those work. How do we add them? How do we subtract them? How do we multiply them? And so on. Okay, so now we're going to look at decimal fractions. So now this is basically a number with a comma in it that we are more used to than fractions. The things that you see on your calculator are in decimal fractions. Okay, so guys, I'm going to read the first part of page 90 for you. It's quite important. So it says, decimal fractions are used to measure quantities such as distance, mass, and volume. A decimal fraction is similar to a mixed number as it can have a whole number part and a fraction part which are separated by a decimal comma. The fractional part always has a power of 10 as a denominator. Okay, so let me just explain what they mean by that, right? So let's say we have a number 3.14, okay? So this is a decimal fraction, right? To the left of our comma, we have the whole parts. So think of this as a mixed number as common fraction. It had the whole part and it had the fraction part. So here's the same thing. This is the whole part, and everything after the decimal comma is the fraction part. Now, what they're saying to us is that every number after the comma is going to have a denominator of a power of 10. Okay, why? Well, remember what we call these. These are our tens, these are our hundreds, these are our thousands, and so on. Okay, so let's continue. The whole number part is written to the left of the decimal comma. If there is no whole number, we write a 0. So if I say a half, that's 0.5. The fractional part of the decimal fraction is written to the right of the decimal comma. Okay, like I showed you just now. Let's have a look at a decimal number and then write it as a sum of fractions. You can see that the numbers to the right of the decimal comma show how many tens, hundreds, thousands, and so on there are. This is called a decimal fraction. Okay, so we're going to use this example over here. So 3.14. So this will equal to 3, which is the whole part, plus we got 1/10. Okay, so 1 over 10 plus 4 over 100. Okay, guys, so as we continue going down the line, the zeros increase in the denominator of that digit going forward. Okay, now let's have an example of, let's say we have 3.2801. Okay, and they say write that as a sum of its fractions. Okay, so this will equal to 3 plus, we have 2 over 10 plus 8 over 100 plus, now we have a 0, so we still have to put it in, 0 over 1000. Okay, obviously it's going to simplify to 0, but I want to see it here so that I know that you didn't skip one. Also, it's useful for you to put it there because imagine you skip this and then you write the next one, but you're counting 10, 20, 30. But this needs to be a placeholder for that 0 so that the next part that you're writing is 1 over 4 zeros. 1, 2, 3, 4. So 1 over 10,000. Okay. So that's quite important, guys. It's like a placeholder. Don't forget about it. All right, so let's look at the examples in the worked example. So it's on page 90. Express the following decimal fractions as the sum of fractions. The denominators must be power of 10. Okay, let's do these examples. So the first number is 0.304. 0.304. Okay, there's the 0. So what does this equal to? Well, we have no whole parts, so there's a 0 there. So we don't need to write a 0 there. It's nothing. Okay. Then the first digit is a 3. This is a 10th. So we got 3 over 10 plus 0 over 100 plus 4 over 1000. Okay. Now in the next step, we can get rid of that. So this will be just 3 over 10 plus 4 over 1000. Again, I want you to show me the 0 over 100 so that it keeps a placeholder for you so that you don't make a mistake. In the answer in the worked example, they wrote the zeros out and they kept 0 out of 100. So I suppose that's okay as well. But we can simplify it to that because the zeros can always disappear. Right, the next one is 3.1415. So that's similar to the one that I just did on the board before this example, the one that I made up with 3.14. All right. Okay, guys, let's look at exercise 7.1. I'll start off some of these for you, and then we're going to get onto rounding off decimal fractions, and you will finish the exercise for homework. All right. So we're on exercise 7.1, page 90. It says number 1, copy and complete the following conversions to decimal fractions. Okay, so now they're giving us a fraction and they say convert it to a decimal. Okay, so let's do that. Oops. Okay, so the first one is 1 over 10. All right, so the first thing that we're going to look at, is there any whole parts? No, there's no whole parts over here, so we're going to have a 0, comma. Now the first digit has tens, so this is 1 over 10, so the 1 goes over there, and it's 0.1. All right, let's do another one. I'll do D for you. So this is A, this is D. So D says 4 over 1,000. Okay, equals, again, no whole parts, 0 point. Now we have 1, 2, 3 placeholders. So for the tens, there's nothing here. For the hundreds, there's nothing here. Now we're going to the thousands, we have 4. So it's 0, 0, 0, 4. Okay. Right, and then the next one, let's do F. 405 over 100. Okay, well, are there any whole parts? Yes, because this is an improper fraction. So we have to change this to a proper fraction first. How many sets of 100 can I take off this 405? 4 sets. So 400 over 100 will give me 4 whole parts. And what are we going to be left over if we take 400 from here? We're going to have this 5 left over 100. Okay, so we have a comma. Tens. Do we have any tens? No. Do we have any hundreds? Yes, I've got 5 left over here. So 405 over 100 is 4.05. Okay. Right, guys, I want you to try the rest of number 1. Let's look at number 2. Write down the value of the digit in color as a decimal fraction. Okay. So we want a decimal fraction. Okay, so we have 2.432. Okay, now the digit in color is this 3 over there. Okay, now they want us to write this digit in this decimal fraction as a, what do they want? So write down the value of the digit in color as a decimal fraction. Okay, but it's already a decimal fraction. I think they mean to go the other way around, because a decimal fraction is already decimal fraction. So if they want us to write the value of that, it will be 0.03. okay, because they're just saying, what is the value of that one? Well, it's this, okay? But it sounds a little bit strange because I would imagine we're going back and forth from one format to another. So if this is not what they're asking, let's convert now this into a common fraction. Okay, how do we do that? Well, we have no whole parts, we have 0 in the tens, and we have 3 in the hundreds. So this is 3 over 100. Okay, I'm suspecting they want us to do this rather than that. But if you want to, you can do both. You can go from here to here. That's also okay. All right, guys, so number 2 is exactly the same as what I've done. So just do the different digits. Number 3, express the following decimal fractions as a sum of fractions with the denominators as power of 10. Okay, so here we're expressing it as a sum of fractions. Okay, so let's do B. I'll do 3B for you. Okay, so 3B says 1.303. 1.303 equals. Okay, so we need to express this as a sum of fractions. Okay, well, whole units we have 1 plus 3/10 plus, we got no hundreds, 0 out of 100, plus 3 thousandths. Okay, and we can leave it like that because that's how they left it in the worked example, so let's leave it. Unless the question says simplify afterwards, then I would get rid of the 0 out of 100 because it's just a 0. All right, guys, so we've done that one. Let's do let's do D. So we have 2.3103. Okay, so nothing difficult. Guys, just remember how this works, okay? Whole parts, tens, hundreds, thousands, 10,000s, and just follow in order. So wholes, we have 2 plus 3 tens plus 1 hundredths plus 0 thousandths plus 3 10,000s. Okay, nothing difficult. Just keep adding the 0 in the denominator as you move the digits to the right. And that's it. Okay, and then to go backwards, you just have to arrange them in this order and then translate backwards. I'm sure we'll get an example like that just now. All right, guys, so that is exercise 7.1. I want you to complete whatever I have not covered on the board. Now we can go to the next section, which is rounding off decimal fractions. Okay, so often in maths, you are required to round off your answers because sometimes they'll say, what is the distance, what is the width of this room, right? Now, I'm not going to sit here and measure it in millimeters and get it so precise that it's, 3,958 millimeters. No one wants a measurement like that. A measurement of, it's 4 meters, it's about 4 meters, is much better than this measurement of 3,000 millimeters. Okay. So what I'm trying to say is that you'll be required to round off your answers. Now, another example, let's say I ask you, how old are you? Okay. The answer that I'm expecting is maybe 12, 13, 14, 20, 100, just a rounded off number. I'm not expecting an answer of 26,000 days or, 325 million hours and so many minutes and so forth. Okay, so the point is that you're required to round off your answers. So I'm going to teach you how do we round off these answers. So I'm going to look on page 91 at the top. I'm going to read the paragraph very slowly, and we're going to try to understand what they're saying. Okay, so when rounding off decimal fractions, we look at the digit to the right of the decimal place we wish to round off to. Okay, so let's have an example. Let's have 2.358. Okay, let's say that is our number. We're going to deal with that. So I'm going to start again. So when rounding off decimal fractions, we look at the digits to the right of the decimal place. So there's the decimal place. We look at these digits because we're rounding off the fractional part, not the whole part. Okay? Unless the question says round off to the nearest hundreds or thousands or something like that. But now we're rounding off the fractional part. If the digit has a value of 5 or more, we increase the digit to the left of it by 1. Okay, so let me give you an example. Let's say I say to you, round off this number to 2 decimal places. Now, 2 decimal places means 2 digits after the comma. So 1, 2. So what this means is that I'll only want 2 decimal places in my answer. So what they just said is that we look at the digit we want to round off. So 2 decimal places, second decimal place is this. We look to the number to the right of that. So we look at this 8 over here. If that 8, or if this number is bigger than 5, or sorry, is 5 or bigger, then we increase this 5 by 1. Okay? If this number is 0, 1, 2, 3, or 4, we keep this number the way it is. Okay? So if we round off this to 2 decimal places, this will equal or be approximate. Now, these wavy equal signs is an approximation symbol, right? Because when we round off, this number does not equal to the rounded off number because we obviously made the number short, smaller, or bigger, okay? So this is an approximation. So now we're rounding off to 2 decimal places. I look to the number to the right. This number is bigger than 5. Therefore, I increase this number by 1. So therefore, my approximation is 2.36. Okay. Right. Let's now think about let's think about another example. Let's round this number off to 1 decimal place. I go to my number 3 over here, 1 decimal place. I look at the number here. This is a 5, so it adds 1 more to the 3. Okay, so this will become 2.4 approximately, rounded off to 1 decimal place. Okay. All right, so now there's an interesting example with the 0 that they talk about, so I'll read that. When rounding off results in a digit that changes from a 9 to a 0, the number is carried to the next digit on the left and the 0 is shown. For example, when rounding off the number 3.096, 3.096, okay, that is our number. For example, when rounding off this number to 2 decimal places. Okay, so let's round this off to 2 decimal places. This is approximately equal to 2 decimal places is 1, 2. We only want to keep 2 places, therefore we look at the number to the right, which is a 6. Okay, this means that it adds 1 more to this 9. Therefore, this becomes a 10. So we write a 0 and this becomes a 1. So what they're saying is that we write 3.10. Okay. Now, the reason why we write the 0 in, because obviously when I write the number 2, I don't say 2.00000 because it goes on forever. I just write the number 2. So why do we have to put that 0 in there? The reason for that is that I asked you in the question to round it off to 2 decimal places, okay? So I want to see those 2 digits, even though this is 0. I don't want to see 3.1, because if I look at 3.1, I'm thinking, hang on, did they round this off to 1 decimal place? Because maybe there's another digit, but they just rounded it off. So if I ask you to round off to 2 decimal places and the last digit happens to be a 0, I want you to keep it at a 0. Okay. All right, let's continue. So let's go to the worked examples on page 91. Round off these numbers to the nearest whole number. Okay, so rounding off to the whole number means exactly the same thing. So the first one, 1.4567. 1.4567. Rounding off to the whole numbers. Here's my whole number. We look to the number to the right. If this is 5 or greater, we add 1. This is 4, so we keep this number the same. So this is approximately 1. Okay, because we rounded off to the nearest whole number. Okay. Number B, so 33.5218. 5218. Is that right? 5218. So we want to round off to the nearest whole numbers again. So here's the whole number units. We look to the right. This is a 5. So we add 1 more here. So this is approximately 34. Okay. Cool. Number 2, round off the following numbers to one decimal place. Okay, 0.4362. 0.4362. They want us to round it off to one decimal place, which is here. We look at the number after it. This is a 3. We keep this number the same. This is approximately 0.4. Okay, guys, so rounding off is very easy. So whatever digits I tell you to round off to, go to that digit and then look at the next number to the right. Then judging on that number, if it's a 0, 1, 2, 3, 4, you keep this number the same. If it's 5, 6, 7, 8, then we add 1 more to the number we are looking at. Okay. Right, so B is exactly the same. C, round off the following numbers to 2 decimal places. Okay, so 2 decimal places, 101.1233. 101.1233. Let's see, 1233, 2 decimal places. So we go to the second decimal place here. We look at the 3, it's less than 5, therefore this stays the same. So this is approximately 101.12. Okay. Guys, to check your answers, look how many decimals you left. Okay, if I say 2 decimals, you need to have 2 decimals. Okay. Right, so the answers are at the bottom there that you can check or practice. You can go through these yourselves. Oops. Okay, guys, so that takes us to exercise 7.2. So what I want you to do is exercise 7.1, what I haven't done, and exercise 7.2. It shouldn't be very long. It will take you probably about 10 minutes. They are very quick. Okay, thanks, guys. I'll see you next time.